Good afternoon, all of you. In today's lecture of class 11 Mathematics Chapter 1, that is sets, we are going to talk about the basics of exercise 1.2. In exercise 1.2, we are going to discuss about three things. One is empty sets. Another is finite and infinite sets. And the last one is equal sets. Okay, so these all are very easy, and the whole exercise is based only on these three topics. So our first is empty set. Empty set means the set which do not contain any element, that is set with no element. Like you can take example, A is our set, that is, now I am writing this in set builder form, where x is greater than 2, less than 3, and x is a natural number. Now x is a natural number and x lies between 2 and 3. Is it possible? No, it is not possible. So what we will say, A is our empty set. Okay. Similarly, you can take more examples, such as we have another set B, that is x is a student studying in class 9th and 10th. Now, is it possible that one student at same time studying in class 9th or 10th, 9th and 10th, sorry, is it possible? Not possible. So again here B is an empty set. Okay. Now its definition. A set which does not contain any element is called empty set. Or you can say empty set as null set or void set. Empty set, null set, void set, all the three means the same. Okay. And how is it denoted? It is denoted by symbol phi. Means now it is given to you. Okay, and they say you to write this in a roster form. Then how would you write it? You would write it as A is equal to phi. Phi means no element. Okay, B is also phi. Okay, means you will represent null set, empty set with this symbol. This symbol is called phi. Or you can use this only brackets, curly brackets. nothing should be written inside it. This also means empty set. Okay, I hope it is clear to you. Now our next topic is what? Finite and infinite sets. Finite sets and infinite sets. I think from its name you understood what are they. Finite sets, the sets which has finite number of elements in it. Finite means which can be counted by you, and infinite sets which contain elements which we are not able to count. Okay, now let us take an example. Suppose they say that C is a set, okay, where X is a natural number. Okay, if they say this, if you write in roster form, how will you write it? This will be 1, 2, 3, 4, 5, but these are many and you can't write them in brackets. Okay, means infinite, all the elements of infinite sets cannot be written in brackets. Okay, so how do we represent them? We write some of their elements like we have written here, and then we use this, and then another bracket. This means it is a infinite set. Okay, and if we make a small change in our set C, that X is a natural number less than 10, then what do this mean? This means C is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. This means our C is a finite set, because how many elements do it have? It has 10 elements. Okay, so what will be the definition? A set which is empty or consists of definite number of elements is called finite. Means these, our set A and set B, are also finite sets. Means if any set has no element or some definite elements, then it is finite, otherwise it is infinite. Okay, like taking example, W is any set where X is days of week. W is X is day of the week. Now you can count them, they are just 7, so it is a finite set. Another they say is D. X is a point on a line. Now you know a line has infinite number of points, so our set D will be infinite. Okay, and our set W is finite. I hope you understood these two terms also. These are values. Okay. Now it is example number 6 given to you in your books, in which we have to state that which of the sets is finite or it is infinite. Okay, now sixth example, first part they are given to you. X belongs to n, and x belongs to n means x belongs to n represents natural numbers, means our x is a natural number, and x minus 1, x minus 2, it is equal to 0. This is the statement given to us. Now we know whenever in our quadratic equation it is given to us, then what do we write? We write either x minus 1 equal to 0 or x minus 2 equal to 0. That means x is equal to 1, x is equal to 2. Means what is our set? Our set is equal to 1 and 2. Only two numbers it consists. So it is a finite set. Okay. Similarly, next second part is x belong to n and x square is equal to 4. Now x square is given to equal to 4. So x square is equal to 4. So from here what do we get the values of x? X is either plus 2 or minus 2. Okay, either of them. But our x belongs to n. Our x belongs to n means a natural number. And which of these two is a natural number? 2. Okay, so our set is consisting only one element, that is 2. So it is finite. Okay, now suppose in place of n they have given z, that x belongs to z. Z means integers. So both are integers. So what would be our set? Our set would be minus 2 and 2. Still it is finite because now it consists only two terms. Okay, like this you can check other also are very easy. Now the last topic of our exercise. Okay, now our last topic of this exercise is equal sets. And I think you understand what are equal sets. Suppose we have two sets A and B, then what you will say? That these sets A and B are equal if the elements of A are same as that of B. Okay. Now say A is any of our set which has elements 1, 2, 3, 4, and B is any of our set whose elements are 2, 4, 1, 3. Okay. Now we know whenever we write elements of set in a set, then the order does not matter. We have to just check that whether the elements are same or not. You can see here it consists 1, 2, 2, 3, 3, 4, 4. Means all the elements of A are same as that of elements of B. So what we can write here? That set A is equal to B. Okay, it was that simple. Now its definition is two sets A and B are said to be equal if they have exactly the same number of elements. It has 4 and it is also having 4, and these are same, so these are exactly same elements. And how do we write them? That A is equal to B. And if we assume that it has, say, 5 here in place of 4, now these two sets are not equal, so I will write them. A is not equal to, okay. Now you can see examples are given. Now see example number 8. Example number 8, first part. Example number 8, first part is x the set of letters in alloy. Means they have given a set x. If we write, I write in this in set builder form. How would I write it? Y is letter in alloy. Alloy is any word given to us. So how would I write it? The set becomes A L O Y. Now I have told you already that whenever two same letters or numbers are given to us, when we write them in roster form, we do not repeat them. Okay, so it becomes this. And now another set B they have given, the set of letters in LOL. Another word they have given, B is a Y is letter in word LOL. Okay. Now what is our set B? Our set B is L O Y A. Now again L is there 2 times, but we will use only once. Now you look here, irrespective of the order, all the elements are same. That means x is equal to B. Okay, in this way you can solve this exercise. It is very easy. In the next lecture we will try to solve all the problems of this exercise if you will have, and the basics of next exercise, that is exercise 1.3. You have to solve this exercise in rough notebook, and if you have no problem then you can also solve it in fair notebook. Okay, thank you.